All right, so in this video, we continue learning about inverse trigonometric functions. In this case, we are going to talk about tangent. Okay, so if you remember, tangent, it's a graph like this. All right, we have the y-axis, we have the x-axis. Maybe we have pi over 2 here, we have pi here, 3 pi over 2, and we have 2 pi. And the same goes on this side, right? We have negative pi over 2, maybe pi, and so on and so forth. And we have 1 here and negative 1 here. If you remember, when you start studying about trigonometric functions, you probably remember that for tangent, you have some asymptotes. That means that the function, the graph of the function, is going to be bound to some values. And these values are going to be pi over 2, at the beginning. It's going to be pi over 2 and negative pi over 2, all right? And after that, every pi, you're going to keep that bound, right? So you're going to keep this bound every pi. Remember that the trigonometric functions are circular functions, so they kind of repeat themselves, right? So now, if you remember, the graph for tangent was something like this, right? And it will repeat here, and it will repeat here, and it's going to be like that, right? The same goes here. Well, that was the graph for tangent, right? And it turns out if you apply the horizontal line test, let's try to do it here. If we try to apply the horizontal line test, the line is going to touch multiple points. So immediately you can say, hey, it's not a one-to-one function. It cannot have an inverse function. But remember that, as we did with sine and cosine, if we bound, well, not bound, I'm not going to use that word again, but if we restrict in which values we solve the function, like I'm doing here, I'm going to restrict the value from negative pi over 2 to pi over 2. Then if we apply the same line test, now we only have 1 point. So that means that the function like this, it's a one-to-one function. So we're going to have an inverse. We can create an inverse function, and we're going to call it the inverse tangent, of course. Okay, so the inverse tangent is going to be defined like this. The inverse tangent, remember that negative 1 on top is going to be, it's going to tell you that it's the inverse. The inverse tangent of x is equal to y if and only if, right? Tangent of y, it's equal to x, right? And this is going to happen, as we just said, if x, it's in between negative pi over 2 and pi over 2, right? If it's in between these two values, then we can have the inverse tangent. Understood? Now, if you imagine the graph of the inverse, we're going to explain this further in another video. But if you imagine the graph of the inverse, then we will have pi over 2 here. We will have negative pi over 2 here. Then here we will have negative 1, and so on. And the graph should be something like this, right? It should be something like this, right? If we try to graph the inverse, right? Because now everything that was on the y-axis, right, is going to be in x, and everything that was on the x-axis is going to be in y. Because if you think about it, if you take one value here, then you, as an input, you get an output here, right? So if you're trying to do the inverse, then you will have an input here, and you're going to get your output back here, and that's why everything just like flips. Okay, this is not the main idea for the video. So what we're going to do, it's solve a couple of problems. So what if we try to evaluate the inverse tangent of 1? Here, what we're looking for basically is, hey, which angle do I need to have in radians, right? That if I evaluate tangent, I will get 1, right? And if you think about it, tangent in a triangle is opposite over adjacent, right? And as a function is y over x, right? This, we analyze it on the unit circle. If you try to analyze it on the unit circle, you will never get 1 because, I mean, y will have a value, x will have a value, and if you divide, you will either get 0 or you will get undefined. So you don't have to analyze it here. But if you analyze it as a circle, remember that you have this triangle, the triangle 45, 90, 45. In this triangle, the adjacent, the length of the adjacent is 1, the opposite is 1, the hypotenuse is going to be square root of 2. If you try to apply the trigonometric ratio, the opposite side is going to be 1, right? And the adjacent is 1. And you know that 1 divided by 1, it's 1. And this is happening for 45 degrees, right? For 45 degrees. I mean, tangent of 45 degrees on this triangle is going to be 1 over 1. That is 1. Okay, so this angle that will give me 1 is precisely 45 degrees. And since we're looking at it in radians, then now we know that 45 degrees is pi over 4. So my answer for inverse tangent of 1 should be pi over 4. Okay, remember that you need to remember how to evaluate trigonometric functions. Okay, and we study in this course, we already studied 2 different methods. For multiples of 30, 60, or 90, we studied 2 triangles, the 45, 45, 90, and the 30, 60, 90. And for multiples of 90, of 0, 90, 180, and so on, we studied the unit circle. All right. So you need to remember that. Let's do another problem. What if we try to evaluate the inverse tangent of square root of 3? Okay. Again, which triangle or which terminal point will have a square root of 3 when we try to evaluate for tangent? Because remember, we're trying to find an angle for tangent that will give me square root of 3. The only triangle that has this value in it is going to be 30, 60, 90. So if that is the case, then let's try to draw that triangle. Make it here, okay? And we have, this is 60, this is 30, and this is 90. And if you remember, the shorter side will be 1, the longest side will be 2, twice as much. And the opposite side is going to be square root of 3. So as you remember, tangent of theta of an angle is going to be, well, let me write it here. Tangent of theta is going to be adjacent, opposite over adjacent, right? And the opposite that works for me must be square root of 3, because if the opposite is square root of 3, then the adjacent that I need must be 1, right? So, and the angle that relates a square root of 3 over 1, having square root of 3 at the opposite and 1 as the adjacent, is 60 degrees. It's this one right here, right? So the angle that works here must be 60 degrees. And we know that 60 degrees, it's pi over 3, right? So the inverse tangent of square root of 3 must be pi over 3, okay? Let's do one last example. All right, what if we try to evaluate arctangent of pi? And do not get scared with this arctangent. Remember that I told you in the previous video that arc sine is exactly the same thing as inverse sine. So this is exactly the same thing as saying inverse tangent. It's exactly the same thing. All right. We need to evaluate this tangent of pi, right? So let's think about this. Tangent of pi. Since this is a multiple of 90, we're going to try to evaluate this on the unit circle. So if we have the unit circle, pi will be here, right? This is pi, 90. I said 90 degrees, but it's actually 180 degrees, my bad. This will be pi, and the terminal point here will be -1 and 0, right? And if you remember, tangent as a function will be y y over x. And y here is 0 and x is -1. So I have 0 over -1, and 0 over -1 will be 0. So I know that all this is 0, right? So this will be equal to arctangent of 0, okay? So if we try to apply the same method, then we're looking for an angle, right? That will give us 0. When are we going to get 0 for tangent? We're going to get 0 for tangent if we have something like this, if we have 0 over a value, right? Because 0 divided by something is going to be 0, right? And if we go back to the unit circle, this is 0, 1. This terminal point is going to be 1, 0. And this terminal point is going to be -1. My bad. It's going to be 0, -1. Okay, so you know that you need to have, if we go back to this, you know that you need to have 0 as the y coordinate. And the terminal points that has 0 as the y coordinate is going to be this one and this one, right? Because look, it's right there, 0, and right here, 0, right? And here on this side, on the right side, this is 0 degrees. And on the left side is 180 degrees. In other words, this is 0 radians and this is pi radians, right? Which one is it? Because if you try to evaluate 0, I mean, if you evaluate tangent of 0, you will get, if we try to evaluate tangent of 0 degrees or 0 radians, 0 will be 0 over 1. And 0 over 1 is 0. And if we try to evaluate tangent of 180 degrees, you will have the same thing, 0 over -1, and 0 over -1 will be 0, right? And now, which one is it, right? Which one is the answer? And it shouldn't be a problem to decide which one is, because remember that we define, let me erase this. We already know the two options. Remember that we define that x, or the angle that we're looking in radians, is going to be negative. It's going to be in between -pi/2 and pi/2, right? And in pi, if we choose this one is greater than this. It's not in between. It's greater. So this one doesn't work, right? It must be 0. Or well, not the 0 radians. It must be 0 radians, because 0 radians is between -pi/2 and pi/2. So this is 0. The arctangent of tangent of pi must be equal to 0. There's no other option doing all that analysis. Okay, I hope that this video it's enough to learn how inverse tangent functions work and how to evaluate them. Okay, see you in the next one.